Uh, Hello students, today we will see disk scheduling algorithm. It is the most important part from unit number 6. 99% problems which is asked related to this topic. So today we will see first algorithm, and in next video I will discuss some examples related to that algorithm. Okay. In yesterday's session we already covered DMA part, direct memory access. In that there are two controllers, DMA controller and disk controller used, right? So when jobs are moved from DMA controller to the disk controller, then that one by one job which is executed by the disk controller and again forwarded to the main memory. So number of jobs those are performed by CPU. That means number of jobs those are performed by DMA controller. That DMA controller jobs are forwarded to the disk controller. But disk controller execute one job at a time. So all other jobs those are resides at a disk controller in a queue. So which job execute by the disk controller and which job which is forwarded to the main memory for execution. So that part or that phenomena which is known as a disk scheduling. So today we will see the disk scheduling which is related to the disk control. Okay. So disk scheduling basic definition related to the disk scheduling. Disk scheduler, it is done by the operating system itself to schedule I/O requests arriving for the disk. Also disk scheduling which is known as an I/O scheduling. So why disk scheduling is important in operating system? As we know, multiple I/O requests arrive by the different processes to access number of I/O devices to CPU. That CPU request again forwarded to the DMA controller, and DMA controller forwarded to the disk controller. But disk controller execute one request at a time. So that's why all other jobs those are reside in a queue. So to schedule that jobs those are reside at a queue, disk scheduling algorithm is used. Okay. Hope so disk scheduling why it is important which is clear right now. Then next, before move towards to the disk scheduling algorithm, some components those are most important related to that algorithm. So among from that first one, seek time. So seek time is nothing but the time taken to locate the disk arm to specify track where the data is to be read or write. Okay. So before move towards to the all theoretical definitions, any disk which is reside at your node. So that disk is a combination of number of cylinders. Number of cylinders those are comprising part of a number of tracks. Each tracks each track consists of number of sectors. Okay. So nothing but disk is combination of number of cylinders. Number of cylinders those are combination of number of tracks. Number of tracks those are part of a or consist of a number of sectors. Okay. So seek time is nothing but to locate a particular arm where we can read or write data. That means from particular sector that identified a particular sector where that sector is resides and where we have to read or write a data for particular IO device. So that time calculation which is known as a seek time. Okay. In short, suppose first of all clear this concept. Disk is a secondary memory, right? So disk is a combination of cylinders. Cylinders are combination of number of tracks. Each track consists of number of sectors. Okay. So to identify, to read and write a data into particular sector, the some time is required. So that required time, which is known as a seek time. The next one, relational latency. So relational latency is a time taken by the desired sector of a disk to rotate into position so that access particular read and write heads. As we know, this combination of cylinders combination of tracks, and tracks particular combination of sectors. So each sector having an head, it is a point. From that point, we can start your read and write. So to identify that particular head, some rotations are required. So that rotation time, which is known as a rotational latency. Okay. The next one, transfer time. It is a time to transfer the data. That means the time which is required to add actual writing and reading the data from this. Okay. So that means how many number of bytes those are transmitted. So that time which is known as a transfer time. The next one, disk access time. Disk access time is calculated nothing but combination of seek time or summation of seek time, rotational latency, and then transfer. So combination of all these three times combinedly known as a disk access time. Okay, I repeat, some important factors those are used for a disk scheduling algorithm. Disk is nothing but a secondary memory. It is a combination of number of cylinders. That number of cylinders is a comprising part. Number of cylinders, those are comprising part of particular tracks. Each, each track consists of number of sectors, and again one sector consists of one head which points to the starting for reading and writing a particular data into the disk. Okay. So first one, seek time. It is a time to locate a particular track where your data should be read and write. The next one, rotational latency. The number of sectors those are moving, and to find a particular positions related to that head, the that time required, which is known as a rotational latency. Then next one, transfer time. How many bytes those are transmitted for read and write, which is nothing but a transfer time. And then next one, the disk access time. Disk access time. Disk access time. It is a summation of seek time, rotational latency, and then next one, the transfer time. The next one, disk response time. Response time is the average time spent by the request waiting to perform its IO operations. So, disk response time is the average time spent by a request waiting to perform its IO operation. So, when the jobs those are maintained in a queue for execution, each operation performs some time in a waiting state. So that average, which is known as a disk response time. Average response time, how many time of the all requests those are executed. And variance response time is the measure to how individual requests are serviced with respect to the average response time. Among from all this time, we required only seek time and transfer time. Okay, for both definitions are clear: seek time and transfer time. The next one, add actual disk scheduling algorithm. In the disk scheduling algorithm, which is categorized into the, or it is consist of 5 algorithms. So among from that, first one, FCFS, FCFS stands for an first come first serve algorithm. Okay, so first come first serve algorithm, in that means among from the job queue, those are resides at a disk controller. So as they arrive, they are picked for execution. So that type of an algorithm which is known as an FCFS, first come first serve. So basic definition, FCFS is the simplest of all disk scheduling algorithm. In FCFS, the requests are addressed in order they are arrived in a disk queue. So FCFS जशा क्यू मध्ये डिस्क क्यू मध्ये जशा रिक्वेस्टेस येतील त्या ऑर्डरने त्या एक्झिक्यूट केल्या जातात. सो नथिंग बट एन FCFS. The next one, SSTF. SSTF is a shortest seek time first. So seek time first, that means the total time required to identify where your data should be read and write in a particular sector. So this definitions which is related to the sector. So SSTF, that means the jobs those are resides in a queue having minimal seek time, those are served first. So that type of an algorithm which is known as a shortest seek time first. Definition for this, request having shortest seek times are executed first, so that the seek time of every request is calculated in advance in the queue itself, and then they are scheduled according to their seek time. Okay, when the desk scheduler consists of number of works or jobs, that time operating system calculate the particular seek time, and depends on that seek time, minimal seek time work first of all execute. So this type of an algorithm which is known as an SSTF, shortest seek time first. Then next one, scan algorithm. So scan algorithm, it is an algorithm which is used to move the pointer from disk sector either inward direction or outward directions. Okay, so inward direction and outward direction, suppose there is a circle, either we have to move from the point to the arc or from arc to the center point. So this type of an algorithm which is worked for an disk. So that algorithm which is known as an scan algorithm. So that means disk is moving. So the pointer first of all start from a specific point position which will either move inward direction or outward direction. If it is move towards to the inward direction, that means suppose there is a circle which will move from the arc to the center point. So if it is moving from this arc to the center point, again from center point it is moving to the arc. That means arc to center point and from center point to the arc. So this type of an algorithm which is used known as a scan algorithm, which is also known as an elevator algorithm. Okay. For example, nothing but in short, suppose I am moving from number 1 to number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And after 10, I am again moving towards to the 1 via 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That means first of all it is in increasing order and again it is in reverse order. So that type of an algorithm which is known as a scan algorithm. Okay, just remember arc to the center point to the arc, or 1 to 10 and again in a reverse order from 10 to 1. So this algorithm which is known as a scan algorithm. The next one, C-scan algorithm. So C-scan algorithm is nothing but a scan algorithm. C stands for a circular scan algorithm. What happens in a scan algorithm? Either you have to move from either inward direction or outward direction. That means from arc to the center point and from center point to the arc. But in circular scan algorithm, arc to the center point, again center point which will move towards to the arc, and again arc which will goes to the center. For example, I am moving from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In scan algorithm, I am reverting that algorithm or reversing that algorithm, that direction. That means from 10, 9, 8, 7, 6, 5, 3, 2, 1, right? But in circular scan, I am moving towards suppose 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, it again goes to the 1 and again move towards to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that means one circle is occurred. That's why it is known as a circular scan. For scan, remember 1 to 10, again in reverse order 10 to 1. For circular scan, remember 1 to 10, again pointer from 10 move towards to the 1 and again it will carry it for 1 to 10. So C scan and then next one the S scan. Hope all these algorithms, two algorithms are remaining which was not included in your syllabus, look and C look. Okay, so basic three algorithms, FCFS, scan, and then next one the C scan. Hope all the concepts related to the disk scheduling and disk scheduling algorithms are clear. If any query, we will discuss tomorrow. Okay. After this, one video which is related to the examples of FCFS scan and then next one the C scan. Thank you.